Welcome back. Here is a fairly tricky problem where we have to work out the coefficient of static friction. Now, this is kind of common in problems when we have an object on a slope and weight will obviously be acting down the way. The normal force will be acting perpendicular to the surface, and therefore friction must be there to keep it static, to keep it where it was, stop it from sliding down the slope. And the force that's going to cause it to slide down the slope is this component here of a weight that will be acting down the slope. So here is the problem. A pair of skis are placed down on a snowy slope which is at 1.8 degrees to the horizontal. The coefficient of static friction between the skis and the snow is 0.030, so no units there. And the question is, will the skis slide away by themselves? So if you want to try this problem, go ahead and hit the pause button and have a go at solving it. Otherwise, here is the solution. So as always with forces problems, the first thing to do is draw a free body force diagram, and that lets you know the relationships involved. So that'll also maybe clarify everything that's going on. So here's a sort of simple version of that. Now, I've divided up the components of weight so that we've got that red component, which is acting down the slope, and that's going to be equal to static friction. And then there'll be a component of weight which is acting perpendicular to the slope, which gives us the normal force and therefore the reaction force. So to start off with, the force of static friction is going to be equal to that little red component there. And we don't know the weight, but we do know that the component of it, which will be, because the weight is the hypotenuse and that little red component is the opposite, we could figure that component out by weight times sine of 1.8 degrees. So that is the component of weight that acts down the slope. Force of static friction is calculated as mu s r, where we've got the reaction force. And the reaction force is equal to that sort of blue component of the component of the weight there. So working that through gives us mu s w multiplied by cos 1.8, which is equal to the weight multiplied by sine 1.8, where we have the reaction force, which is the one in blue there. Now, what this means is if the first part of this expression is bigger, because that's going to be equal to the force of friction, than the component of weight which is acting down the slope here, then the skis will slide. So everything at the front of this end equation, if that's bigger than w sine 1.8, then the skis are going to slide. So let's see what happens. We start off with this equation because we're trying to figure out what we already know. We've got the coefficient of static friction, which is 0.030. So let's do a little bit of algebra there. The weights will cancel. And here's a sort of useful trigonometry rule that crops up quite a lot in multiple choice questions. The sine of theta over the cos of theta is equal to the tan of theta. So that leaves us with tan of 1.8. Sine divided by cos equals tan. Now, taking that, if you punch that into your calculator, tan of 1.8, it will give you approximately 0.0314. And because that is greater than 0.030, the skis will indeed slide away. There you go.